Now in this next video, we're going to take the concept of head and pressure and make it a little bit more complex, right? Where in the previous example, we just looked at a reservoir with a given amount of water in it. What pressure would we measure at the bottom of that reservoir? We're going to kind of take those simple hydraulics and complicate it one step further. So in this example, we're still going to start out with some said reservoir, right? Filled with water. Let's just say in this example, there's 30 feet of water in this reservoir. Okay, it's a pretty tall reservoir, right? We can measure the pressure at the bottom of this reservoir. But we also know that this reservoir is going to end up feeding a whole community down the line, right? So this is going to represent my water pipe bringing water down to said community. And then what we're going to look at, though, we're going to think about a fire hydrant that's down here. And this fire hydrant, we're also looking at what is the pressure down at that fire hydrant. Now, the information I'm going to be given in this problem is really, okay, what is my height of water in my reservoir, right? That's going to give me a certain amount of pressure at this point because of that head, right? 2.31 feet of head is equal to 1 PSI or 1 pound per square inch. Now, this fire hydrant, the reason I drew it like this is because this fire hydrant is actually located lower in elevation, right? Lower in height than this reservoir. Think of the reservoir as kind of being on top of some hill, and then this hill is going to run this way. Now, the location of the reservoir relative to the fire hydrant, let's just say that we are looking at a 30-foot difference in height, right? Or a 30-foot difference in elevation from the bottom of the reservoir to the fire hydrant location. So now what I'm going to try to do is I'm going to ask you, given the information here, what pressure am I going to measure at this fire hydrant in PSI? Right. So now I've got to look at not only the head that I have added with the water in the reservoir, but I have to look at the difference in height here from the hydrant to the bottom of my reservoir, which we're going to refer to as our altitude head, right? It's created because from some point we have raised up our source of water, giving this water more potential energy, right? And that potential energy is what we refer to as this concept of head, which is going to create a certain amount of pressure. So let's just say that now we want to figure out what is the pressure at this hydrant. So this pressure here is going to be equal to the head we created in our reservoir plus the head we created by having the reservoir higher than our fire hydrant. So in this case, we are looking at a height of 30 feet plus another 30 feet, right? 30 feet from the height of water in the reservoir and 30 feet from the altitude difference from the base of the tank to my fire hydrant, right? So you can almost think of it as we're looking at the distance from here down to here, which is going to give me 60 feet, right? That is my total difference here. So now when it comes time to figuring out this pressure, now I can look at this 60 feet of head, right? That's what my total head is. And in order to convert that to PSI, I know that I'm going to need to divide that by 2.31 feet of head for every 1 PSI, right? My feet of head are going to cancel out, and I'm going to be able to get to just pounds per square inch. So in this case, in my calculator, 60 divided by, right, it's in the denominator here, divided by 2.31, that's going to give me 25.97 PSI. Right. That's the pressure I would measure off this hydrant, given the fact that my reservoir is 30 feet higher than that in elevation, and given that I have a water level in my tank of 30 feet as well.